It is a tool that simplifies communication experience of users via such chat suggestions. So we provide the model with dialogue and ask to give a suggestion of continuation of the dialogue. After that, we show it to user, and user can choose one of them as draft for his own message. Now we have a little time. Let's proceed to the question, why do we need to train our own model? Good way to understand it is prototyping. You can implement an API of a good model, measure the impact, and estimate possible benefits of your own model and costs. So what's in our case? We have implemented message suggestion via Frontier Models API. We asked 2 times to continue a dialogue. After that, we measured effect in A/B test. So the effect wasn't only product, it was even financial. So we became very optimistic and decided to train our own LLM because we will have less API costs and more flexibility in usage. And also we expect that our model will be better than just out-of-box API. Sometimes it feels like a roller coaster. On one hand, it's like poor OpenAI, everybody uses them just for prototyping. And after that, they might not be needed anymore. They are definitely going bankrupt. On the other hand is poor our data science department. It could be replaced by just GPT for Omni with just one prompt engineer. We will definitely get fired. But at this point, we are closer to the first point. So let's discuss details of measuring quality. Before that, we need to understand why actually do we need that quality measurements. In some sense, it is a step-by-step process. While training your model, you are trying to use different approaches, like different architectures, different data sets, different learning steps, and so on and so on. After that, you go to quality measurement, and it says, was that step right or not? In some sense, we can use a metaphor of reinforcement learning, where we've started our random walk of changing the configuration of training process, and our quality measurement says whether the step was right. So here is like red arrows, they are bad changed, and green arrows good changed. Let's proceed to the ways of quality measurement. I will discuss. I would like to highlight 3 ones. Benchmarks. Here I mean only token scoring tests and LLM as a judge, Oracle. No human evaluation here. I'm sorry. No human evaluation here, because I want to discuss human evaluation separately. The second one is online metrics or A/B testing. And the third one is human evaluations, or how we can call it offline signals. So online signals while the model is in production, offline, not in production. Let's proceed let's discuss benchmarking in more detail. Let me remind you a concept of Oracle benchmark. Oracle is a good model, frontier model, that answers our questions about models' responses, or about our models' outputs. For example, for dialogue, you can measure tone of voice, how much tone of voice of your model's output is consistent with the dialogue. For example, you give a prompt, does the tone of the answer match to a dialogue? System prompt, you are an expert in something, in people communication, give me an assessment. And there are lots of interesting details about benchmarking, but it's not the main. It's not the main theme of my talk. So I will just mention one nice life hack. It is structural responses. It is a service from ChatGPT where you get not just a textual answer, you get a full fields of a structure you give them. So it's very comfortable because you can easily simulate chain of thoughts, like ask several preliminary questions to the LLM. And after that, you'll get like numerical answer for your metric. It's very useful because you get desired format. And even good models sometimes struggle with preserving format. Now, what are pros and cons? Benchmarks are very easy and fast to compute. You can launch lots of measurements. They are quite cheap. And you can address specific issues that are important. In our case, for dialogues, it's like empathy, proactivity, relevancy, ethics, lack of harm, truthfulness, and so on and so on. Now, what are disadvantages? First disadvantage is very similar to the last advantage. It's the problem that nobody knows what exactly you need to measure. What exactly is important for example, conversation. And even if you know what is important, it's not very easy to calculate it properly. The methodology can differ very much. Also, there are some issues with Oracle's noise, because it is not perfect, and its quality, in some sense, is our limitation, because our model, our generator, couldn't be much better than our discriminator, our Oracle, and it could have like low quality in a desired field. Now let's proceed to online metrics. Its metrics you compute while A/B testing. They are very close to production, and it's very good. You can compute product metrics, you can compute profit, and so on. Here is in. Why do we need this in? I don't know. In different segments. I understand my presentation. Also, you need only your A/B platform that usually is already developed in your business. What's the problem? First problem is gaming online metrics. It's more or less common knowledge that if you use online metrics as a target in your training process, you will get some undesired outcomes. For example, if you are ranking pictures for your search engine, you are ranking pictures. If you use online signal, you will definitely get some provocative images at the top, some clickbait images or maybe sexual content images. So here is the problem, and it works also for our product, because if our Copilot starts to send clickbait messages or sexting messages, it could even improve our product metrics for a while, but it is bad for our product in long term. Another issue is a distribution of a random dialogue. Imagine usual dialogue on a dating service. Most of them are like, "Hi, how are you? I'm not interested, goodbye," for example. Yeah? You have lots of very simple dialogues that didn't really reveal the model's desired model abilities. You need some very specific dialogues to reveal them. And also, weeks to get result. An average machine learning engineer could produce several models a day or several models a week. But you have to wait 3 weeks to get the result. Was that model good or not? Also, we need deployment. We can attach some bugs to our production. And also, while we are doing A/B tests, we can measure weaker models there. For example, if you have imagine you've trained a very good model within 2 stages, fine-tuning and reinforcement learning. And after that, you want to try a new approach in fine-tuning. Then you need to deploy 2 weak models, only fine-tuned, and to compare them. So you will have a drop in your quality in like 10 or 20% of your business. Now let's proceed to human evaluation. What's interesting and what's one of the main differences of actual AI assistants, copilots, and good old LLMs? A very big difference is that these assistants and copilots, they are product. So you can measure their quality as a quality of a product. And in this case, you can try to build a metric, single metric that defines your quality. For example, you can use quite intuitive metric. How useful is this response for the communication? People spend lots of years on communication. Nowadays, often textual communication. So it's very easy to find an expert who will assess you whether this response is good or not. You can make even very simple scale, like this is useful or somewhat useful or pretty useful. If you need more precise comparison, you should use comparative metric because, for example, side by side, it's when you give a dialogue and 2 continuations, and your assessor marks what answer is better. Now, it's also known fact that to make a comparison is much easier than to make this absolute estimate. Because imagine comparison is just a 1 bit of information, so to say, like A is better or B is better. And this scale is harder to define because in every context it can differ. So a good choice for your single metric, it's a win rate against some anchor models like Sonnet and ChatGPT, just a win rate. And imagine how much it is more comfortable to use one single metric instead of dozen of benchmarks, dozen of metrics that are measuring something. And here is a step to the ground truth, which is quite useful. Now let's let's discuss in more detail online versus offline. For offline, you need to spend some resources, like.
Can I ask a question?
Yeah.
Please explain how is data get in all 3 scenarios? How is these data are given to the system?
Well, I think it's a detail. Let's discuss it in break. Yeah. You need to hire guys to create markup infrastructure, instruction development, train your assessors, and usually you have your A/B platform, but you don't have all this infrastructure, all these resources. So it's very tempting to say, let's use only A/B tests. We'll find right segments of dialogues, and everything will be okay. What's the problem with this approach? Let me introduce a metaphor for coach training a volleyball team. What is online test? Online test is like overall score. You can track records of your team in tournaments. There are lots of tournaments. You can compute different scores, different consider different situations, and so on. And offline is more like training, with not on tournaments, obviously. What's the problem with that approach? To make proper training of your team, you need not only overall score, you need to decompose skills of your team. For example, do you have a good attacker? Do he knows how to spike or drop ball properly? Do you have good defense, and so on and so on? You can try to find overall tournament records. I don't know. You can watch lots of replays of that team and find the moment where your team member need to do something special, something you're looking for. But it is much easier to set that situation in offline, in training. You can pose your team members where you want to start the situation that you want and measure what you want and work on it. So when you try to find interesting segments in your A/B test, you struggle with two following things. That, for example, you need some classificator. Classificator is not accurate, perfectly accurate, so you will get there some noise. And the second problem, it is that the segment could be very small, and you will have lack of statistical significance. So it can lead to bad decisions. Now let's proceed to final scheme I propose. Final thing is as follows. We use benchmark for preliminary selection of models. So for very bad red arrows that goes back. After that, we selected several candidates. We compute their offline metric. We compare them with good models and select the best of them with this process. And after that, we only fix our profit. We compute product effect, business effect via A/B test. How much time do I have?
3 more minutes.
3 more minutes. Well, I have quite interesting. It is only a low resolution scheme. I have some details, but I think that these slides are quite dense and complicated, and I don't want to rush through them. So thank you for attention.
So what about low-level frameworks which you use for online training? Do you use something like Radas, Ares, or something your own library?
We started with something like Jumpstart and BlackRock, and now we are moving to our own framework.
Yeah, thank you very much for the talk. I have a question. As a whole, the whole system has a lot of features in recommendation system, because basically it recommends text and other stuff to users. I would like to know, is there a user-specific approach in your models? Because a lot of times people differ in their preferences drastically. So a lot of people prefer texting in some kind of ways and others don't. And I would like to know if your models are flexible in that sort of way, so they can learn user-specific approaches and user-specific recommendations.
Well, we provide the model with metadata, like the age of guy, the interests, the preferences, just in prompt. Now, our product is quite young, so only by this simple approach.
Yeah, thank you very much.
Yeah, okay.
Yep.
Yeah. Thank you one more time.